Welcome back, crew. This is the second part of our notes on quadratic functions review. We've already looked at how to factor quadratics. Today we're going to look at how to solve quadratics. So we're going to come down in these notes to the bottom of the third page, where we start talking about solving quadratic equations. So you know that when we solve an equation, we're looking for the value of x that would make the equation true. So here I'm going to look at finding the exact, that would be without calculator, and then the approximate solutions to the quadratic equation x squared equals 3. Right, so there are two ways to solve this. Right. One is that although with a quadratic we typically want it to equal 0, my ultimate goal is to get x by itself. So if I come in and I take the square root of both sides, right, then I get x. But really, when I take the square root of x squared, what comes out of the square root has to be positive, but what x is doesn't necessarily have to be positive. And so the square root of x squared is actually the absolute value of x. So I have the absolute value of x is the square root of 3, which means x itself could be either positive or negative square root of 3. So that's one way. I get two solutions for a quadratic equation, which is absolutely what we would expect, right, from a second degree polynomial. Another way for us to solve this equation is to actually get it equal to 0. So if I subtract 3 from both sides, and then to factor this as a difference of squares. So if I do that, in the first spot of each parentheses, I want to put what will multiply to give me my first term, x squared. So that's going to be x times x. In the last spot of each parentheses, I want to put numbers that will multiply to give me 3, which could be 1 and 3, but if we're a little creative, right, I could multiply a square root of 3 by a square root of 3 to give me 3 as well. And if I do that and make one of these binomials plus and the other one minus, then I create a difference of squares that if I multiply back together, I get x squared, right, minus root 3x plus root 3x minus the square root of 3 times the square root of 3, which is minus 3. So that works. If I set that equal to 0, then my next step would be to set each factor equal to 0. And if I set x plus the square root of 3 equals 0 and solve for x, I get x equals negative root 3. If I set x minus the square root of 3 equal to 0, then I get x equals the square root of 3. So I get two answers for x, and they are the same answers for x that I got this way, a little quicker. But to do that, you've got to remember that you don't just get one answer, you get two, one positive and one negative. Okay, so let's go on and do some more difficult ones that have more terms. We're going to solve by factoring. Our first step is that we're going to get the equation equal to 0. Our second step is that we're going to attempt to factor the quadratic side. We're going to set each factor equal to 0 and solve. If we can't do this, then we're going to use the quadratic formula, but that won't be our first choice. That will be our second choice. So here's our first example. I have x plus 1 times x plus 3 equals 15. Okay, a lot of students are tempted to take x plus 1, set it equal to 15, and take x plus 3 and set it equal to 15, and that doesn't work. So making this number 15 doesn't mean that this number will be 1, and vice versa. So that doesn't make any sense, doesn't work, we're not going to do it, so let's take that away. What we are going to do is we want this equation equal to 0. So I'm going to subtract the 15, and I've got x plus 1 times x plus 3 minus 15 equals 0. Now we're going to simplify this side, so we're going to multiply these two together, and we get x squared plus 3x plus 1x plus 4x plus 3 minus 15 equals 0. Combining these two terms together, we get x squared plus 4x minus 12 equals 0. That's a quadratic in standard form. We want to factor that quadratic, and that will factor as, let's see, x plus 6 times x minus 2 gives me negative 12, multiplying 6 and negative 2. My outers give me negative 2, my inners positive 6, that gives me positive 4x, so that works. So if those two, right, parentheses, which represent numbers, equal 0, then either one of them is 0, which means it doesn't matter what the other one is. Anything times 0 is 0, or the other one is 0. Those give me equations with just an x, solve for x, and I get x equals negative 6, or x equals 2, and I have two solutions. I have negative 6, and I have 2. Right? No problem, you've done this before. Let's do another example. So here I have 2 times x plus 3 squared equals 5 times x plus 3. I know that's a quadratic equation because I have an x that would be squared. So that makes it a quadratic equation. To solve a quadratic equation, we want the equation equal to 0. So I'm going to take this. I've got 2 times x plus 3 squared. And I'm going to subtract what's on the other side, 5 times x plus 3 squared, x plus 3. And that now equals 0. If I simplify this left side, right, following PEMDAS, doing exponents first, I get 2 times x plus 3 squared is x squared, plus 2 times x plus 3, so plus 6x, plus 3 squared, plus 9, and then I have minus 5 times x plus 3 equals 0. I'm still simplifying this left side, do my distribution to multiply, and I get 2x squared plus 12x plus 18. Distributing my negative 5, I get negative 5x minus 15 equals 0. Combining my like terms, I only have one quadratic term, 2x squared. Positive 12 and negative 5x give me plus 7x. And then positive 18 and negative 15 give me plus 3 equals 0. I want to factor that if I can. So I would need 2x and x to multiply together to give me 2x squared. I would need 1 and 3 to multiply to give me 3. So if I put the 1 here and the 3 here, then my outers give me 6x, my inners give me 1x, and if I make those both positive, right, then my last multiply to give me positive 3, and my outers and inners combine to give me positive 7x. So that works. I'm going to take each factor, set it equal to 0, solve for x, and I have two solutions, negative 1/2 and negative 3. If we check those in the original equation, if I put negative 3 in for both of my x's up here at the top, this becomes 0 squared, which is 0 times 2 is 0. The right side becomes 0 times 5, which is 0. That works. If I put negative 1/2 in, negative 1/2 plus 3 is negative 1/2 plus 6/2, which is 5/2. Right? 5/2 squared is, let's write this down. So plugging in x equals negative 1/2. 5/2 squared is 2 times 25/4. Right? 5/2 times 5/2, which is 25/2. On the other side, I have 5 times 1/2 plus 3, which is 5 times 5/2, which is also 25/4. Right? So both of those equations work. All right. So if a quadratic won't factor, which happens sometimes, we can solve a quadratic by using the quadratic formula. We've done that quite a bit this year already, so I won't go over that. Let's look at this example. I want to solve this quadratic equation. First thing I'm going to do is get it equal to 0. And since x squared is positive on the right side, I'm going to move everything to the right side. So I've got 0 equals x squared. Subtracting my 2x from both sides, I get minus 2x. And then subtracting 11, I get 11. I can try to factor this. So I would have to have x and x here. My only options to get 11 would be to have 11 in one binomial and 1 in the other. And no matter what my signs are, there's no way for me to make 1x plus 11x equals 2x. So that's not going to factor. Let's take that back out and go back to where we were. was at x squared minus 2x minus 11 equals 0. Only if that equals 0 can I use the quadratic formula to solve, and it would tell me, right, that this variable, x, right, which is squared here, will equal the opposite of my b, opposite of negative 2, plus or minus the square root of my b, which is negative 2 squared, minus 4 times my a is my coefficient of my quadratic term, times c, which is negative 11, all over 2 times 1. I simplify that and I get positive 2 plus or minus the square root, right? This is 4, and these multiplied are plus 44, and that is all over 2. So I have x equals 2 plus or minus the square root of 48 all over 2. This 48, this 48 is the same thing as 16 times 3. So I can break up that square root over multiplication, never over addition or subtraction, and that is 4 root 3. So that gives me x equals 2 plus or minus 4 root 3 over 2. I can take this division by 2 and I can distribute it to either side of the plus or minus sign. So I get 2 over 2, which is 1, plus or minus, right? So I did 2 over 2. I also have to do this. 4 over 2 is 2 root 3. And those are 2 answers, which is what I expect, and that is my solution for this quadratic equation. Okay, I think that's it. Oh, let me go back. I wanted to show you an alternate way for solving this. So I'm going to come in here, and you've already got this in your notes, and I'm going to take us back. Oh, I'll come back. I'm going to take us back to here. I'll leave those answers there so we can compare. So we had this, and I'm going to come in here and bring it back to where we were. Come on, baby. So I got 2 times x plus 3 squared minus this 5 times x plus 3. After your experience in factoring, maybe when you saw this, you noticed that there was a common factor between the 2 terms on either side of this subtraction sign. If I factor out one of those x plus 3's, there's my x plus 3. My other factor is what's left when I divide each side by an x plus 3. So here I get 2 times x plus 3 squared divided by an x plus 3 leaves me 2 times 1x plus 3. Then I have this minus, this 5 times x plus 3 divided by x plus 3 leaves me with just 5. Right? Now I have x plus 3 times, simplifying inside this group, I get 2x plus 6 minus 5 equals 0, which gives me x plus 3 times 2x plus 1 equals 0, which would give me x plus 3 equals 0, 2x plus 1 equals 0, so x equals negative 3, or x equals negative 1/2. Same answers here that I got when I did it the other way, and quicker, right? So that's great. Factoring is a powerful tool that can help us do a lot of things. All right, I think that takes care of it. You've got a couple problems to do tonight where you solve by factoring, and I'll see you tomorrow.